In example number 1, we established that if y is equal to arcsine, then y prime was 1 over the square root of 1 minus x squared. Okay? And then, for example number 2, we're given y is equal to arctangent. Well, if you had to find the derivative of this, how would you go about doing that? Take a guess.
Same thing, move tan over it.
Yeah, do the same thing that we did before. We would hit both sides. We'd take the tangent of y, and then the tangent of the arctan. So when you make a composite function of the inverse and its function, you're left with, in other words, these two cancel x. So we've got tangent of y equals x. Differentiate both sides of the equation. Now what's the derivative of tangent?
Secant squared.
Secant squared of y, and then because we're deriving this implicitly, we tack on dy dx whenever we take the derivative of the variable y. And this just becomes 1. So now we've got, well, when we solve, we get dy dx is equal to 1 over secant of y squared. Now, what does that mean? Well, believe it or not, we would address this issue like we did on the last one. We've got secant of y squared, and we would love to have that something in x. So we're going to have to do some substitution. Now, whenever you see something squared, whenever you see a trig function squared, automatically think in your head Pythagorean identity. So let's look at this. I've got sine of y squared plus cosine of y squared is equal to 1. Now how do I get 1 over secant? What is that equal to?
1 over
What is secant the reciprocal of, I guess is what I'm trying to say.
cosine.
Cosine. So now how could I want to change one of these into secant. So what could secant is what?
1 over cosine.
1 over cosine. Could I do this? Divide this by cosine squared? Yeah, but what do I got to do algebraically? Got to do it to everything, right? So when I divide everything by cosine of y squared, this changes things. Hey, what's this? Tangent of y squared. What's cosine of y squared over cosine of y squared? 1. Secant of y squared. Wait a minute. Could I do this? 1 over 1 plus tangent of y squared? Why, yes, Mr. Adams. Boy, if I just had some relationship between tangent and x.
Tangent of y equals x.
Hey, so what do I replace that with?
That one.
That one. So what does it look like?
1 over 1 plus x squared.
Yeah, so it'd be dy, everybody said the same thing, that's correct. It would be dy dx is 1 over 1 plus x squared. Alright, because we're just going to take this and square both sides to get tangent squared. So tangent of y squared is the same as x squared, right?
Yeah.
Okay. Well, that was pretty easy.
Is that it?
For the most part, yeah.
Why is that?
Now, informally, probably what we should do is start talking about u substitution. One way that we could write this, and so I'm going to write the formula. I kind of skipped it on the last one because I wanted you guys to soak in how we derive these first. So what I said is if y equals tangent inverse of x. We just proved that if I derive that, y prime was equal to 1 over 1 plus x squared. But some formal notation might look like this. d dx of tangent of u is equal to 1 over 1 plus u squared du dx. And that's important because at some point in time, we're going to plug something in other than x.
Like a number or like a number?
Yeah, like what if we're, like, at some point, what if I gave you the function like y equals arctan of x plus 2?
Oh, I thought you meant just.
So if that's the case, then what would I do? Well, that's exactly what example number 2 is addressing. So how would I go about doing that?
Same thing you started to?
Yeah, so let's build on that, okay? So what Mr. Adams is saying is that technically, to be a little more formal, the derivative of tangent of something, the arctangent of something, is equal to 1 over plus the something squared times the derivative of the something. So the actual example problem number 2 is the, we're trying to figure out, we're given, well, let me just read it right out of the textbook. It says a particle moves along the x-axis so that its position at any time t greater than 0 is x of t is equal to arctan of the square root of t. What's the velocity? So if this is the position equation and they want to know what the velocity is, how do I find that? Yeah, I got to take the derivative of that. So what I really need, the velocity of t is really x prime of t. So now, to do x prime of t, I've got to do a couple of things. First of all, we need to establish what is u. Well, u is equal to the square root of t. So what's du? What's the derivative of that? 1/2 t to the negative 1/2, right? If we use the power rule, remember this is t to the 1/2.
Yeah. Oh, I didn't know that. That's a fun rule.
So now what I need to write then is that the derivative of this is 1 over 1 plus whatever u is squared. And then we tack on du. In this case, it would be like du dt. Because it's a derivative of time. So really, I have 1 over 1 plus the square root of t times the quantity 1/2 t to the negative 1/2. Well, when you take the square root of something and square it, what are you left with?
Just what's under the radical sign.
The base. Yep. So this becomes just t, right? And then that's multiplied by 1 over 2. And then how do I deal with this negative issue?
Multiply it by -1.
Well, I've got a negative power. So how do I make the power positive?
Put it under 1.
Yep. So I could do that, right? And I'm writing out each step on purpose. I mean, if you could skip a step in your head, I'm okay with that. So what does this mean? Well, this means that I've got 1 plus t times, 1 times 1 is 1, right? So we'll say times 1. And then on the bottom, I've got 2 square root t, which is just 1 over, and I'm going to toss the square root 2 root t to the front times 1 plus t.
Why did you bring the square root back?
Because you
Well, because we're going to plug it in, because the second part of the question is, what is this evaluated at t equals 16? So right now, and I could even distribute the square root of 2 times root t through the parentheses if I wanted to. I could do that. I could say 1 over, and if I push that through, I get 2 root t, and then plus, this one doesn't get any cleaner. It's like 2t root t. Your textbook does it a little different, but... And this is the velocity. So I did all that work, but it wasn't a lot of work. I'm just taking the derivative. So v of t is equal to x prime of t, which is equal to 1 over 2 times t, the square root of t, plus 2t times the square root of t. And I just distributed that through the parentheses.
I feel like that's not even...
So then the second part of the example number 2 is what's the velocity of the particle at t equals 16 seconds? So what I'm going to do is I'm going to say v of 16 is equal to x prime of 16, which is equal to 1 over 2 times the square root of 16 plus 2 times 16 times the square root of 16. So the square root of 16 is 4. 2 times 4 is 8. Yeah, you always focus on the principal root unless otherwise asked. Yeah, and I'll explain that in a second. Let me finish where we're at. This 2 times 16 is 32. The square root of 16 is 4. 32 times 4 is, what is that? 136? No. It's 128. 128 is 136 is what I was thinking when you add them all up. So the velocity at 16 seconds is equal to 1 over 136 units per second or whatever. And so I'm glad that you mentioned that question about roots, square roots, right? So whenever we take the square root of something, it's a plus or minus, right? Unless when we do like physics or we do calculus, we always assume the principal root unless they instruct us otherwise. If we were to work this problem out and we considered the negative roots, we get a different answer, but we would find that that's erroneous sometimes.
I don't know what that means.
It just means it's not important. But it's a good question, but 95% of the time, the clue to look for, it'll say find all solutions. So like for example in the textbook it doesn't say what are the velocities of the particle, right?
Yeah.
And if it were to say velocities, then that means you would consider both the positive and negative roots. Where this stems from, yeah, there's no indication that we should consider that, but they do exist, right? They do exist. Good. Any questions on this one? I don't know why you guys were